In the good old days, there was plenty of timber. So much so that you could build a floor or walls or anything using only the very best wood that nature had to offer. Nowadays, however, we make more efficient use of wood. Instead of harvesting old-growth forest, we grow plantation timber, such as pine. However, if we want to use this timber in traditional roles, it has to be modified or engineered. We can veneer it to make plywood, or lay the veneer all the same way to make LVL or laminated veneer lumber. Or we can chip it and make particle board. From fibre, it can be made into medium density fibreboard or melamine.
I designed this new kitchen and family room space using a variety of timber products. These included chipboard, MDF, LVL and plywood. The factors that influenced my choice of materials in each situation included wear and tear, structural considerations, cost and the look of the product.
Logs from the pine plantations are firstly cut into lengths that the equipment can handle. The logs are fed into the flaker, where knives cut them like a planer.
We have a drum at the bottom of the magazine, which is 180 knives, which turns the billets into flake with about 0.6 of a mil.
The flakes are different sizes according to whether they're for the centre or the outside of the board. The flakes at this stage have approximately 50% moisture, so they're dried in this rotating drum, which works like a giant clothes dryer. The drum rotates at exactly the right speed for the flakes to not quite make it to the top, so they tumble through the hot air passing through the drum. The flakes are mixed inside here with urea formaldehyde, a moisture-resistant resin, then laid onto a mat sitting on aluminium plates. The call plates, as they are called, are made of aluminium because this stops them from reacting with the resin and marking the boards. The plates go into a press called a daylight press. It's called that because you can see daylight through it when it's opened. After a few minutes, the press opens and the cycle repeats. The hot boards go into the cooler that allows excess formaldehyde to escape before it is trapped in the pack and delivered to the customer. The call plates are then returned to the head of the line for the next batch. Every hour, the strength of the glue is tested. Boards destined for floors are usually more water resistant. They are grooved and a tongue put in position.
The joins are machine joined, so when they come out from the factory they're very straight. So when you're laying your floor, it's best to make sure that you keep those machine joined together all the time. So if you're cutting the sheet, you don't put the cut side on the machine joint, so then you get a nice join. You've got to make sure that when you lay this stuff that your floor level is spot on, or your joists, you know, leveled and perfect, because if this stuff goes on and your joists are up and down, then it's not going to be suitable. That's your tongue. That just comes out whenever you want. Sometimes you don't need it, so you just take it out, but all that does, it slips in there like that. And then your other sheet hits into that, and that's what bonds it together. There's different grades with this stuff. This is called a yellow tongue. You can get a yellow tongue, a green tongue, a red tongue and a blue tongue, and they're all different grades of timber, and that allows you to space your joists out at different centres. That's a green sheet there. It's just got an anti-fungus in it, and that's what we use in the bathrooms in the wet areas. We could put a tarp over this, lays on this until all the job goes up, and then later on, once the whole job's finished, they cut the tarp out in individual rooms, and then people usually carpet straight over this stuff.
Often, particle board is coated with a laminate, usually melamine, which is also known by its brand names, Formica and Laminex. The laminate is made of layers of paper dipped in melamine formaldehyde resin, which then go into a 3-stage oven. In the assembly area, the board is built up with 3 sheets of core paper and a sheet of surface paper. On the top, a press plate gives it its texture or glossy finish. Then it's heated to set the resin. The laminate is cut to size in preparation to go to factories where it is bonded onto particle board. This particle board is then used to make bench tops and kitchen cupboards.
The main product that we use is this chipboard, and we use it for several reasons. The first reason we use it is because it's moisture resistant, which means that it can be given a 10-year warranty against any sort of dampness or any explosion due to moisture. This material only comes in white colour, and we use it for the carcasses, for the internal of a kitchen or for the internal of a wardrobe, and for kickboards and other unseen parts of the kitchen. We put edge tape on the chipboard to match the edge to the panel colour to get a complete finish on the job. This machine here we call an edge bander because what it does is it applies edges to boards in various colours. The edge tape we use has got glue already applied to the back of it, and what we do is turn the machine on. It'll heat up a blower which will in fact heat up the glue and then apply it to the edge of the board.
These cabinets were covered in plastic laminate, and in this situation chipboard was used to stick the laminate onto. We could have used MDF here, but chipboard's a lot cheaper. There's a lot more cabinets with this surface on it, so obviously it was a cost factor here. You don't need quite the same fine edge you do with the real timber because the plastic laminate's thicker and it's more rigid. The cupboard doors in the kitchen has plastic laminate on the outside, but on the inside it's just white melamine, which is a lot cheaper to use, and because you don't see it, that's why it's just left white.
The next material we use would be the MDF, like you see on this drawer front. And the reason why we use that is not only because it's also moisture resistant, but because it can come in a wide range of colours and can be formed to be moulded if necessary, like this board here, with detailed forms holding their strength and holding their pattern. This is actually MDF with plastic vacuum formed over the top of it.
The logs in this factory are chipped in the forest. The truck has a walking floor, so it doesn't need to tip the whole tray up. A screen separates the oversized chips and passes them through a chipper. To soften the chips, they are cooked by adding steam under pressure. The chips are fed into a refiner, which is 2 grooved plates. One rotates and the other is still. The chips are fed into the center and are thrown outwards by the spinning. The grooves reduce the chips to fibers. The glue is urea formaldehyde and is brought in by the tanker load. It is not very clear, but the glue is added here to the chips and they swirl along the pipe, and this helps them to bond together. The fibers of wood pulp are laid in a mat. This blue spray tells the customer that this particular glue is water resistant, so can be used on floors that may get wet while building. The edges are trimmed and the mat is compressed between plates to the desired thickness and density. A metal detector would tell the line to dump any section with metal. Otherwise, a person could be hurt later on when using the material in a woodworking environment. The thickness is measured by this nuclear radiation device. The thickness gauge then controls the feeding of the fiber onto the board. The mat then goes into the section of heated rollers. The heating is called radio frequency heating, which is another version of microwave, but at a lower frequency. The radio waves make the water and wood molecules vibrate in time to the radio waves. And this movement is heat, which helps the urea formaldehyde to set. The boards are then cut to length, usually a standard length, to make warehousing easy. But if an order was large enough, special lengths could be programmed in. To see if the boards are up to spec, samples are taken and tested every 15 minutes. No factory could afford to produce a bad product, so testing is critical. Here, the boards are tested to destruction for MOR, or modulus of rupture, as well as internal bond strength and water absorption. The boards are cooled in this rack. If they were stacked hot, the heat would take months to get out, and there would be all sorts of problems.
All the architraves and the skirting boards in this new part of the house are MDF, and it's a profile which matches the old part of the house exactly. It was cheaper than using real timber, which was used in the original part of the house, but we get exactly the same look once it's painted. MDF was used to do the cupboard doors. It's solid, it's 35 millimetres thick. MDF was chosen because these doors are 2.7 metres high, so they had to be strong. A hollow core door would not have withstood that height. This cabinet here, which was made out of timber veneer, so we've got real timber, which is onto a base of MDF. MDF was used because we wanted a very fine edge, and it's the best and most stable product in this application.
Pine plantations are grown in a 40-year cycle. Each year, one of the forests is harvested, either as thinnings or as fully grown logs. First of all, the bark is taken off because it's not as strong as the wood. The logs are cut to 2.5 meters, which is just over the standard width of the veneer.
When you peel a log, you're peeling sapwood, which is the best veneer. It's very wet, it's very dense, it is very strong, and then you start to get into the heartwood layers. The heartwood is the exact opposite. It's drier, it's softer, it's spongier, it's weaker because it's less dense, and that is where the cores are.
This is where the veneering takes place. Because the rings of the tree are off-centre, the veneer contains both heartwood and sapwood. The veneer is graded. The weaker heartwood can be used in the centre of the board, where strength is not required. Small pieces of veneer go to the veneer composer, where they are squared off.
The random narrow pieces are held together in 6 places. The nylon string is coated in glue and it holds the sheets sufficiently together so that you can move it and glue it later on. Waste material, including what comes from the veneer composer, all the offcuts from there, they're hopped up into and installed.
The veneer is 50% moisture, so it needs to be dried in the oven. The veneer is classified into 5 grades. A grade has no blemishes and is for walls and furniture. B grade can have some small defects that are filled with putty and is used for furniture, house sheathing or concrete formwork. The glue used in formwork is phenol formaldehyde, which is extremely waterproof. To make the surface smooth and easy to release from the concrete, the surface is coated with a paper impregnated with this resin. C grade has larger defects that are also filled with putty on the face. Once it has been through the sander, it can be painted. It is used in building. D can have knots and splits that are not filled with putty. It is used for structural purposes where it won't be seen, such as bracing walls of buildings. Plywood is strong because it is made by gluing the sheets of veneer together. Every second sheet of veneer is turned 90 degrees and thermosetting glue is spread onto one side of each sheet. Then the pack is squeezed in a cold press that spreads the glue onto both sides and holds the pack together until it reaches the hot press, where the glue sets. The square pack is then cut in half to make the sheets a standard rectangular size. The plywood at this stage looks incredibly ragged, so the edges are trimmed off.
So that is now going to the trim saws. The trim saws cut the end pieces off and it gives you a good place and gives it a nice clean surface.
This room is a very long space, and so that walls and columns could be avoided and we could have a nice clear open space, we needed a beam. So it had to be made of a product that would take the span. This is plasterboard covering up the beam, so you don't see it, but inside there is a very long beam of LVL.
Laminated veneer lumber, or LVL, is like plywood, but all the veneer runs the same way. The beams holding up this roof are LVL. LVL is made in very long lengths from standard pieces of veneer that are laid overlapping each other, like tiles on a roof. The top is continuous and is scarfed to produce a smooth surface with a strong join.
3 layers down, 3 layers up, a scarf, all the others are butted together so you get butt holes. So what this does is provide a smooth surface like this.
Again, the assembly is cold pressed to hold it together enough to reach the hot press, where the glue sets. Once out of the hot press, the board is ripped into widths using gang saws. Some of it is used to make I-beams.
The pieces you see behind are these pieces. They're your LVL pieces. Feeding them into the machine